which then brings us on to maximal strength testing. So we're going to look at max strength testing as we did with grip strength and isometrics. We're going to focus on max strength testing here, but under isoinertial conditions. And the most common technique that is used is the 1 and 3 rep max. And not surprisingly, you might be doing things like squats or bench presses in the 1 rep max condition. That's the maximum load that can be lifted only once. And to get to that point, you might increase the resistance by anywhere between 2.5 and 10 kilograms. You may want to reduce that resistance down as you get closer and closer to where you think it's going to be. And we have a significant rest up between each lift, and we go to the point of failure. And the last repetition that can be done without failure is considered to be the 1 rep max. And it's been reported to have good test-retest reliability. And I've put reported because it's been reported using correlations. So they've correlated the first trial against the second trial. Well, the problem with that is correlations are not measures of reliability. We've focused on this a little bit in previous sessions. So although the evidence, which is the old evidence, is well, it's highly it's highly correlated. It's reliable. We need to question that because our understanding of the way in which we assess reliability has changed quite enormously. So here we've got some data, and what they've done is they've got data for men and for women, and you can see they've got it for the bench press, for a squat, and an arm curl. And what they've done is they've done multiple sessions. They've done 4 sessions, and what they're comparing is the association, so the reliability between sessions 1 and 2, 2 and 3, 3 and 4, and they've used what is called an ICC to do this. An ICC is an interclass correlation. It is a form of correlation, but it's a much more sophisticated correlation. It's not like using Spearman's or Pearson's, as we saw previously. The key thing to understand, as with all correlations, is the closer that number gets to 1, the greater the reliability becomes. So what they're arguing here is if you take the men bench press data here, 0.95 between sessions 1 and 2, good repeatability. Between sessions 2 and 3, good repeatability. 3 and 4, good repeatability. In other words, shown to be actually very reliable data. But when we go to the squat, and you see that by the way in the females as well, when you go to the squat, look at the male data here, actually it's the same with the female data, but particularly the male data, sessions 1 and 2, not repeatable really compared to what you're seeing in sessions 2 to 3 and 3 to 4. It's a much lower value. Same in the females, it is lower, particularly than what you see at sessions 3 to 4. So this tells us that if we're going to do this, we've got to do this test more than once, which of course is quite a big time commitment. We've certainly got to do it more than once. And actually it suggests that you probably need 2 to 3 repeats to be certain you've got a reliable squat 1 rep max. If we're talking about the bench press, you can probably actually get away with just 2, a single repeat of the process, doing it twice to get reliable data. In the females, similar results, okay, particularly with the bench press. With the squat, you probably the 1 to 2 sessions, but it seems to be that you probably need to do maybe even 3 sessions, because you notice that it suddenly increases significantly in sessions 3 to 4 in both groups. And so this actually hints that reliability is not there in early, doing 1 or 2 squats. It's not repeatable because of stabilization issues and probably poor technique. But it also alludes to the notion of actually how many familiarization trials do we need in order to get reliable data. So we may well call these sessions 1, 2 and 3 familiarization, and then count trial 4 as our actual measure of 1 rep max. Now in the data set that we've got here, what we've got is a series of Bland-Altman plots, so using limits of agreement. And what they've done is they have they've repeated this. So what we've got is bench press men, which is our top data here, and this is between sessions 2 and 3. We've got bench press women between sessions 1 and 2. We've got squat men, sessions 2 and 3, and squat women, sessions 1 and 2. So there's a little bit of variance, but Let's look at the bench press in the men for the moment. So what we are looking for is, this is our bias score. So that's the mean of the differences between, on a test retest, is between these two sessions here. So we've got a bias score of just about 2, right? It's about 2 kilogram bias. Then what we want to look at is the spread of the data. So the data is sitting within inside our 95% confidence intervals, which are these two lines here. But what it's suggesting is across sessions 2 and 3, the 95% confidence intervals go from about 3 kilograms in the positive to over 5 kilograms. In fact, I think that's over 6 kilograms in the negative. So it's a 9 kilogram difference on a test retest basis in a bench press, suggesting actually that at least 3 familiarization sessions will be required. What we want is, as we see in this example here, the bench press women, this is sessions 1 and 2. Look at the variance now. It goes from about 4.2 to around about 1. So there is only about a 3.1, 3.2 kilogram difference between the two trials. The confidence intervals are closer to the bias score, suggesting they've got much, much better repeatability. In the squat, remember that the squat is a much, much more complex task. Look at the difference in the complexity of the task. In that bias score, yeah, mean of the differences in this example here is actually in the region of about 2.5, but it goes from a positive score of about 9 to a negative score of close to 12. So you've got in the region of about a 21 kilogram difference between trials 2 and 3. And then in the females between 1 and 2, females in this example seem to be much more proficient in the squat, but the same principle applies. There's still quite a large variance, so suggesting that in both these groups more familiarization trials would be needed to ensure that we've got reliable data. So this is why limits of agreement and Bland-Altman plots become really important to us in kind of establishing this. So we can see this in this data set here. So what we've got is we've got bench pressing and squatting, and we've got sessions 1 to 4. We've got our non-experienced group and we've got our experienced group. And what I want to focus on is, let's deal with the bench press in the experienced athletes, and you'll see 76.5, 76.5, 77.1, 77.4, very, very consistent. Now look at the bench press in the non-experienced athletes. 52.5, 54.2, so we've gone up by 2 kilograms within one session. 56.1, we've gone up by another 2 kilograms. 57.5, we've gone up by 1.5 kilograms. So the difference is a 5.3 kilogram difference across 4 sessions. So this is really informing us that if we want to get reliable data, we need to have, in this example here, at least 3 familiarization trials in the non-experienced bench pressers. The same is also true if you look at the squat data. You'll see very good consistency in the experienced athletes. Look at the novice or non-experienced athletes. 104.9 ends up at 116.6 by trial 4. So an enormous difference of 12 kilograms across 4 trials. And so it really does lend itself to this notion that we have to employ familiarization to satisfy us that we've got reliable data for evaluating strength. And we reinforce that a little bit with these Bland-Altman plots. So this is again looking at that same data set, but looking at it in a slightly different way. So what we've got is the non-experienced in panel A, and this is between sessions 2 and 3. And then we've got the experienced in panel B between sessions 1 and 2. And so don't be fooled, you're not quite comparing like for like. So remember, you've got the mean of the differences on this column, and then you've just got the mean for the 2 sessions here. So the mean of the differences between sessions 2 and 3 goes from a positive of about 5 to a negative probably about 3. So even after 3 sessions, there's still an 8 kilogram difference. Although all the data is sitting, it looks very tight, is sitting within these 2 values and around the bias score, there's still a large difference in these athletes. Between sessions 1 and 2 in our more experienced athletes, there's near enough a 20 kilogram difference is what it's suggesting. And you've got 2 athletes sitting outside the 95% confidence intervals. So it actually suggests that in this group of experienced athletes, they probably needed more familiarization trials to ensure that we're getting reliable data. And so it really does lend itself to that reference right at the start from Jarek of this lecture, which was one of the fundamental issues with this kind of testing is that the ability and the technique of the participant plays an enormous role in the outcome. Now, let's think about this in the context of this reference here from Taylor and Fletcher. And in this reference, they write the findings, they're referring to their study here, the finding that the 8 repetition max test was reliable might be explained by the use of a familiarization session and the objectivity of the 8 rep max test procedures. A study by Levinger also used a familiarization session prior to 1 rep max testing, the results of which showed that 1 rep max testing was reliable. So both are suggesting that if we simply bring people in and just assess the squat, and you just do it, and you maybe do it 2 or 3 times because you think that's right, you've got unreliable data in both scenarios, whether it's 8 rep max or 3 rep max or 1 rep max. But if you count the first number of trials as familiarization, and then in essence you only count the final trial, that is a much, much better indication of maximal strength isoinertially. And if we then refer to these Bland-Altman plots here, and what we've got, these are quite neat. So on the x-axis, we've got the mean propulsive velocity. This is the rapidity which the bar is moved. And then we've got the differences between trials 1 and 2. So this is the repeatability. But what they've done is they've changed the condition. They've done a standard movement, which is on the left panel, and then they've done a paused movement. So what happens in the paused movement in the bench press is as the bar comes down, they pause, and then they move the bar. There isn't a single kind of movement. But notice what the ramifications of that are. We go from a positive value here, where there is no pause, of around about 0.07 to a value here of around about 0.09. So an overall difference of about 0.16 milliseconds. Okay? You might go, okay, so, but now look what happens when we take the pause out. Okay, so, sorry, when we add a pause in, apologies. So now when we add the pause in, look at the difference. We now end up at around about 0.5 and we go to 0.5 here. So we've got a 10 millisecond difference. So actually, fundamentally, this notion of adding the pause in actually reduces the variability in the data. And so particularly when you're kind of looking at rates of force development, that becomes very, very important. It becomes less of an issue if you're just simply interested in the max strength value itself. So how does that help us? Well, if we look at this reference here from Polaris and colleagues in 2014, they write this. The main findings of the present study were that 1, biological within subject variability for the bench press and the squat exercise is significantly reduced when a pause is imposed between the eccentric and the concentric phases of each repetition. And 2, low reliability in barbell velocity was observed for loads greater than 80% of the 1 rep max. So they're really informing us that that pause is important, particularly, you know, in the squat. We've just seen it in the bench press, but in the squat and the bench, it allows you to reduce the variability in the data. And when we're talking about kind of having data that is both valid and reliable, that seems to be a technique that should be employed when doing this kind of testing. And then this kind of one of these final things to show you is just to kind of show you within the test retest. So here we've got, this is 8 repetition max scores, so rather than 1 rep max, and we're comparing an initial test to a test retest, and you can look at this in the chest press, the pull down, the row, the overhead press, and actually what you see, there is some variability going on. It looks like the chest press is fairly consistent. Pull down, actually that's quite a big difference between the two here, 53.7 to 56.1. So it does suggest that actually you perhaps need more than one or 2 familiarisation trials. The row is okay. If we then look at overhead press, that's over a 3 kilogram difference. Again, more than 2 familiarisation trials would appear to be needed. And then this final Bland-Altman plot that we've got here. So this is for 8 repetition max. This is test retest on this, and it's quite an interesting thing to show. So again, we've got the mean of the difference. So this is kind of the mean of the difference between the two. And what you can see on the test retest, we go from a -5 to a positive 25. So this is fascinating. That this is suggesting to us that there's about a 30 kilogram difference on a test retest basis using isoinertial testing of 8RM. So it really lends itself to how unreliable this can be, and why we need to have more and more familiarisation trials to reduce the variability and increase the reliability of these data sets.